multiplying binomials. So first we'll discuss what a binomial is, but before we get to that, we'll look at what a monomial is. So if you remember from grade 9, a monomial is a single term expression. So here we have 3 that's being multiplied by a 2-term expression, which is called a binomial. So when you guys did polynomials in grade 9, you talked about the difference between a monomial, a binomial, and a trinomial. So for this example, we're looking at multiplying a monomial by a binomial. And you guys may remember how to do this. So we use something called the distributive property, where you multiply in this first term to both terms inside this set of brackets. So here, if we multiply 3 times 2x, we get 6x. And if we multiply 3 times positive 3, we get 9. So this is the distributive property. You guys learned this in grade 9. You've done a bit of it so far in grade 10 as well. So here we're going to look at multiplying 2 binomials. So here, this first set of brackets, we've got a 2-term expression, 2x plus 3. And in the second set of brackets, we have another 2-term expression, which is x minus 4. So we're going to look at multiplying binomials using the distributive property. So method 1 is the distributive property. So everything in the first bracket, the first set of brackets, gets multiplied by everything in the second set of brackets. So this is also called FOIL. So you may have heard of FOIL, which basically means you multiply the first things that are in the expression together, and then you multiply the outsides it doesn't say outsides. The outsides, so the 2x, and this would be the negative 4. The 2 inside terms get multiplied, and then the 2 last terms. But to make it easier, we're just going to call it the distributive property and go about it the same way. So if we use the distributive property, this 2x gets multiplied by x here. The 2x also gets multiplied by the negative 4. So when we do that, we get, so 2x times x, I'm going to have to write it, is 2x squared. Then we've got 2x times negative 4, which gives us negative 8x. So we've taken care of this first term. It got multiplied by everything in the second set of brackets. Now we need to take this this positive 3 and multiply it by everything in the second set of brackets. So this is, again, distributing this 3 to the second set of brackets, which actually looks a lot like this. We're taking a 3 and we're putting it into a set of brackets. So here we've got 3 times x, which would give us positive 3x. Remember, you need an operation like addition or subtraction between each term. Then here we've got a positive 3 times a negative 4, which gives you negative 12. And then you want to simplify. So if you notice, you've got a negative 8x and a positive 3x. So for like terms, you want to make sure that it has the same variable and the same exponent. So this is the same variable. The exponent is assumed to be a 1. This is if we can't see it. We assume that it is a 1. So here we are going to simplify this expression to 2x squared. So negative 8 plus 3 gives you negative 5x minus 12. So that is how you multiply binomials using the distributive property. So I'll work through this example. I'll do this one slightly quicker. So here we're going to have x times 4x to give me 4x squared, and then x times -1 gives me -x. So first term in the first set of brackets is multiplied, then you're going to take the second term and multiply it by everything. So positive 2 times 4x gives me positive 8x. Positive 2 times -1 gives me -2. And then again, we're going to simplify. These terms here are like terms. So 4x squared cannot be combined with an x because it has an exponent of 2. -x plus 8x gives me positive 7x. So if you're not sure, you can use your integer, or if you're not sure about the integers, you can use your calculators to solve. And then -2. So that's using the distributive property. You can also use a chart form. So when you use a chart, you're going to create a chart that looks like this. And then you're going to put a multiplication because we are multiplying these terms. So up here on the top, you're going to put your first term. So our first term is a 2x, just taken from this bracket, and our second term in that first set of brackets is a positive 3. In our second set of brackets, we've got an x. Oh, I shouldn't use red. We've got this. So we've got an x, and then we've got a -4. So when you use the chart form to multiply, you're just simply multiplying x times 2x, which will give you 2x squared. You multiply 2x times -4, which would give you -8. Oh. -8x. Oh my. 3 times x is 3x. And then 3 times -4 is -12. So to simplify it, again, you've got like terms here. So you've got a -8 and a positive 3. So your final answer would look, you've got your 2x squared. You've got your -5x. And you've got your -12. So I'm going to leave the second one for you guys to try. You're going to get the same answer that we got here, but I just want to make sure, or you just want to practice doing the chart form. When you're solving these types of questions, it doesn't matter which method you choose. Just stick with one and master one. So 2 ways to do the same thing. So it says try these. So I'm going to use distributive property to solve these questions. So I'm going to distribute x into here. So if you remember from grade 9, when you multiply x's, you same base, you add the exponent. This is where the x squared is coming from in the previous slide. So x times x is equal to x squared. X times 2 is positive 2x. And then we're going to distribute the 3. So 3 times x is positive 3x. And then 3 times 2 is positive 6. So if you followed the pattern, you're going to realize that these two numbers in the middle here are always going to be combined because they'll be like terms most of the time. So 2x squared plus 5x, whoops, that's a plus, 5x plus 6 is your final answer. 2x squared plus 5x plus 6. So same thing here. Distribute, and then distribute here. I'm going to write it. So 2x squared, or 2x times 3x gives me 6x squared. So I have to write in the squared. 2x times -2 gives me -4x. Then I'm going to distribute the bottom here, so -3 times 3x gives me -9x. And then -3 times -2 gives me +6. And then our final answer would be our 6x squared. And then we're going to collect these like terms. -4x minus 9x is -13x. And then our +6 at the end. So this x squared follows. So that is distributive property. And what we did here is we multiplied those two terms. So one thing we need to know is when we see this type of expression. So you know if you see 3 squared, that's basically saying it's 3 times 3. So the same thing is true when you see a binomial, so two terms inside of brackets with a squared. So you need to expand the binomial. So if it says expand and simplify, it wants you to expand it. So it wants you to show that you are able to recognize that 3x plus 2 in a set of brackets with a squared on the side is the same as 3x squared plus 2 times 3x squared plus 2. So it wants you to see that you know that this is the same thing. So to simplify means to expand it. So here we're going to use distributive property. So 3x times 3x is 9x squared. Three x times +2 is 6x plus 6x. And then we've got 2 times 3x gives us +6x. And then finally 2 times 2 gives us +4. We do not need a bracket here. And then lastly, collecting like terms, we're going to get 9x squared because it's the only x squared, so it stays by itself as a squared. And then 6x plus 6x gives you plus 12x, and then plus 4. So just be familiar with how to expand a squared binomial. So here are a couple application questions, and then that'll be it for this lesson. So it says a 2-lane bridge has a width of x plus 3 and a length of 4x plus 5. Sketch the rectangle with these dimensions. So if you're going to sketch it, you're going to have a rectangle, has a width of x plus 3 and a length of 4x plus 5. That is an x. So this is part A. You're just going to draw out that rectangle. Part B says find a quadratic expression that represents the area. So what a quadratic expression is an expression that has a squared exponent. So it's basically what we've been doing with these binomials. Is you want to find a squared exponent. So if you were to use a quadratic expression, oh my gosh, that was supposed to be a B. You are looking for area because that is when you're multiplying these two binomials. So area is equal to length times width. So in this case, our area is going to be x plus 3 times 4x plus 5. So it's not quite a quadratic yet because we haven't expanded it to get that squared exponent. So expanding it will make it a quadratic. So x times x, 4x, is 4x squared. X times 5 is 5x, so plus 5x. 3 times 4x is positive 12x. And 3 times positive 5 is 15. Move that squared back over. And then collecting those two terms in the middle to show that they are like terms. Area is equal to 4x squared plus 17x plus 15. Plus 17x plus 15. Oh, and lastly, a rectangular ski area has a width equal to 1 plus, or x plus 1 and a length equal to x plus 3. Both measures are in kilometers. Find a quadratic expression that represents the ski area. So again, we're looking for area of this. So part A, area is equal to length times width. So we've got area equals x plus 1 times x plus 3. So not quite a quadratic expression yet. We need to distribute it to make it have a squared exponent. So x times x is x squared. X times 3 is 3x. Don't forget your signs in between. 1 times x is x, or 1x, so positive x, and then 1 times 3 is positive 3. So again, simplifying by collecting the like terms in the middle, our x squared stays as an x squared. Then you've got 3x plus x is equal to 4x plus 3. Part B says calculate the area if x is equal to 2 kilometers. So part B, we're going to use this expression here because it's an area expression. So we've got area equals x squared plus 4x plus 3. And then we're going to sub, every time we see an x, we're going to sub in 2. So area equals 2 squared plus 4 times 2 plus 3. And then we're going to solve to find that area. So 2 squared is 4, plus 4 times 2 is 8, plus 3. Area is equal to 4 plus 8 is 12, plus 3 is 15 kilometers squared. So that is the lesson on multiplying binomials. This is your homework. I will give you guys the selected questions. Just check the weekly schedule.